Today we're going to be looking at the question number 2 from the 2010 exam, and I've classified this as both a type 1 and type 5 question. Type 1 largely because we're focusing on rates and accumulation, and then type 5 is calculus from tables, so anytime we're using a table winds up being a type 5 problem. So, a zoo sponsored a one-day contest to name a baby elephant. Zoo visitors deposit entries in a special box between noon and 8 p.m. The number of entries in the box T hours after noon is modeled by the differentiable function. Good to know that it's differentiable. For time 0 to time 8. Values in hundreds of entries at various times are shown in the table above. So 400 entries, 1300. Use the data in the table to approximate the rate in hundreds of entries per hour at which entries are being deposited at time 6. So part A is asking us to figure out what is E prime of 6. What is the rate at time 6? So E prime of 6, we look at the table. 6 falls between 5 and 7, so the best approximation that we can do for the rate of E of t would be to calculate the average rate of change between these two times. So that would be E of 7 minus E of 5 over 7 minus 5. Or if we evaluate these, 21 minus 13 over 7 minus 5 is 8 halves, or 4. And then 4, this is our in hundreds of entries per hour, so 400 entries per hour. So around time 6 p.m., the number of entries being put into the box are 400 per hour, approximately. This is worth 1 point. If you have the correct answer, that is your 1 point. Okay, and oftentimes units are part of these questions, and in this case we were not required to include the units, so all you need to have is the value of 4 with the supporting work that leads to that. Okay, going on to part B. Part B says, use a trapezoid sum with 4 subintervals to approximate the value of 1/8 integral 0 to 8 E of t. So we are trying to evaluate 1/8 integral 0 to 8 E of t. And we're going to use the trapezoidal sum to do this, and it says 4 subintervals. So we're going to do 1/8 times our t sub 4 for that function. So trapezoidal sum of 4. So let's evaluate t of 4. Okay. T of 4, we're looking at our table, and our first trapezoid goes from 0 to 2. Our second one goes from 2 to 5, 5 to 7, and 7 to 8. So there's our 4 trapezoids. The value for the area of the trapezoid, if you want to use the word area, is going to be average of the bases times the width of that trapezoid. So there's my first trapezoid. My second trapezoid is going to be average of the bases times the width of the trapezoid. So base 13, base 4, with a width of 3. My next trapezoid has bases of 21 and 13 and a width of 2. So it looks like I'm going to run out of space here with my bracket. Average of the bases of 21 and 13 times a width of 2 units. And then the very last trapezoid, average of the bases of 23 and 21 times the width of that base or the width of that trapezoid. 7 to 8 is a width of 1. Okay. So keep in mind, the trapezoidal sum is just the integral. We can't forget to include that 1/8 to evaluate our value. So this is approximately 10.687 or 10.688 if you're going to round. Now this is a numeric answer, so you can stop at this point for the calculations, but it's nice to always see what it comes down to. And the meaning of this, well, we're doing 1 over b minus a integral a to b of a function. So this is going to be our average function value. So they ask us to find the value and then interpret the meaning. So this is the average function value, and the function tells us the number of hundreds of entries in the box between noon and 8 p.m. Okay. So this is worth 3 points. You get your first point if you have the trapezoidal sum, which I've written in right there. Then if you remember to multiply it by 1/8 to come up with the value of what you're trying to approximate, that's your second point. And then your third point comes from the meaning. So this meaning right here, average number of hundreds of entries in the box between noon and 8. And remember, you need to specify the interval of time to get that full meaning put in there. So 3 points. Right. All right, moving on to part C. So, and I guess I should have written this here. This is calculator active. Calculator active. Okay, so part C. At 8 p.m., volunteers begin to process the entries. They process the entries at a rate, P of t, hundreds of entries from 8 to noon. According to the model, how many entries have not been processed by midnight? So at 8 p.m., we have 2,300 entries, and then we are going to start processing them at this rate. So in part C, if we start with 2,300 entries, and then we start taking away entries from 8 to noon, this integral represents the total accumulation of entries being removed in hundreds of entries. Using a calculator, we can evaluate the integral of P of t from 8 to 12. So Math 9 pulls up the integral command, 8 to 12 of the function t cubed minus 30t squared plus 298t minus 976 dt. Now I of course used x's because my function is set up in, or my calculator is set up in function notation. But it's an arbitrary variable. As long as we're consistent here and here, we'll get the same answer. This provides us an answer of 16. So between 8 and noon, 1,600 entries were processed. So 23 minus 16 is a total of 7. This tells you how many have not been processed yet? I started with 2,300, I processed 1,600, so I am left with 700 entries. This is worth 2 points. 1 point for the answer, 700 entries, and then 1 point if you knew to integrate the rate function. All right, and on to part D. According to the model, at what time were the entries being processed most quickly? So if P of t represents the rate that they are being processed, and we're asking when are they being processed most quickly, we are going to be asking for what is the maximum of P of t. Maximize P of t. What is the rate that P of t is the greatest? So this is a candidates test problem. We're looking for an absolute maximum. So step one, we need to find the critical values, the times where P of t is equal to 0. There's our critical values, and our goal is going to be to evaluate P at our endpoints and P at any of our critical values that we find. So let's turn to our calculator to find where these critical values are. What I'm going to do is I'm going to put P of t into y1, x cubed minus 30x squared plus 298x minus 976. I'm going to adjust my view window so that my time span goes from time 8 to time 12. We're looking for where is P of t, P prime of t equaling 0. So having a x, oh, I messed that up. The x's should go 8 to 12, and my y should be negative and positive. Okay. Now, if I were to graph this, this is going to be asking when is P of t equaling 0. Well, we want to graph where P prime of t equals 0. So let's turn this function off, and I can either hand write the derivative here, or I can have the calculator do the derivative for me. This is a pretty basic derivative, so I'm going to hand write it myself. 3x squared minus 60x plus 298. But if you wanted to have the calculator do the derivative for you, which is a safe thing to do, you can press math 8, which pulls up the derivative command, take the derivative with respect to x of the function y1, vars, y vars function y1, as x equals x. So that's the way you would have the calculator do the derivative for you. Okay, let's graph this and see where does the derivative equal 0. So we're going from 8 to 12 on the graphing screen, and this is the graph of P prime of t. We see there are 2 locations, so we're going to need to calculate the 0 of both of those locations. So I can calculate 0. This looks like around 9.2, so we'll go from 9 to 9.5 and move our cursor to about the guess, 9.183. So at t is approximately 9.183, which I'm going to store as the letter A. So we can press second quit, X store as A. So now it's stored in A for me. Go back to my graphing screen and do the same thing for this point. 9, 10, 11. This looks to be around 10.8-ish. So second calculate 0. We'll go from 10.5 to 11, and then move the cursor around 10.8. Again, we'll store that as a variable 10.816. Okay. So to wrap this up, we're just going to need to evaluate P of A, P of B, and P of the endpoints and see which one of these is the minimum. Since I have P stored in Y1, I can have my table do this for me. So If I go to second table and the setup is already set to ask, second table setup set to ask, we can go here and type in 8, returns a value of 0. 12 returns a value of 8. A returns a value of 5.0886, roughly. And then B returned a value of 2.9113, approximately 2.9113. Our goal was to find process most quickly, so of which of these is the maximum. P of t is at, let's write that. Let's do it this way. Absolute max of 8 at t equals 12. So entries are being processed most quickly at time 12, where we're processing 800. Okay, so there's 3 points for this. First point, consider p prime of t equals 0. So knowing that you had to find the critical values. Finding the candidates, A and B, so actually recognizing those as well as the endpoints. Sorry, all 4 of them are candidates. So 1 point for p prime, 1 point for the candidates, and then 1 point for your answer. All right, thanks for watching. Smash that like button, ask good questions, conquer the world.